All right, guys, welcome to Analyzing Linear and Exponential Models. Today's where we kind of put everything together. So go ahead and read this. A science experiment involves periodically measuring the number of mold cells present on a piece of bread. At the start, I'm just going to highlight some keywords here. There are 50 mold cells. Each time an observation is made, the number of mold cells triples. Okay, so for example, at observation 1, there are 150 mold cells. So the question A is it linear or exponential? And I'm hoping that because of the word triples, you guys would have known that that was exponential. And then write the model. So remember, the model is y equals starting value times rate to the x or t power. Oh, they have x here. Let's use x. Okay, so what do we plug in for what? A is the starting value, so 50. So it's y equals 50. B is the doubles or triples. So if it's triples, it's going to be a 3 to the x power. So this is your model. And then let's see if you guys can fill in this table. To fill in the table, you could just keep multiplying by 3. Or you could take this number and just plug it in for x and see what you get. But I think for this one, it's just easier to just keep multiplying by 3. So 150 times 3 is 450. 450 times 3 is 1,350. Times 3 again is 4,050. And times 3 again is 12,150. Okay, and then part C says, what about on the 50th observation? Now, I guess you could just keep multiplying by 3, but much easier would it just be plug 50 in for x, since x stands for the observation number. Okay, so we're just going to plug in 50, and it's going to be y equals 50 times 3 to the 50th power. And if you calculate that, and please do this with me, I mean, it's going to be a huge number. It's 3.59. Let me show you what this looks like here. This is scientific notation. 3.59, E means times 10 to the 25th power. So 359 times 10 to the 25th power mold cells. It's just a huge number. And then part D says, can you sketch a quick graph? So we're going to draw the x and y axis here. And what I want is labels. So the x-axis is the observation number, and the y-axis is the mold count. Okay, so I want I want the labels, and then I want, see how it says significant values? That means I want the y-intercept. Okay, so the starting value was 0, 50. So you guys are going to make a dot at 0, 50 and label it. And then I just want, what does the general shape look like? So it's an exponential growth. So all I want is then for you to show that it's a curve going up. Okay, so we need labels, y-intercept, and quick sketch. All right, let's try one more. Number 2. All right, so let's read about Julie, and let's figure out if it's linear or exponential. So initially, she has a $40 credit. Every minute of talking costs 15 cents. Okay, would that be linear or exponential? Okay, so it's 40 bucks, and then it keeps costing 15 cents each minute. That would be linear because you're losing 15 cents a minute. So the model for linear is y equals mx plus b, and let's see if we can figure out what m and b are. Well, the starting value is 40, so b is going to be 40, and then every minute you talk, you lose of 15 cents of the credit. So it's going to be y equals negative 15x plus 40. Okay, that's like our slanted model there. And then fill in the missing numbers of the table. You could plug these values in for x, or you could just keep subtracting 15 cents. Oh, I wrote that wrong. 15 cents, not $15. 15 cents. So 39.85 minus 15 cents is 39.70. Minus 15 cents is 39.55. Minus 15 cents is 39.40. Minus 15 cents is $39.25. Okay, so that's the table. Now C, find the value of f of 10 and explain its meaning in terms of the phone. Okay, so f of 10, if you guys remember function notation, it means you plug in 10 for x. So let's take 10 and let's plug it in for x. All right, so on the calculator here, it's negative 0.15 times 10 plus 40. And you get $38.50. Now the question's saying, what does that mean? What does that number represent? Well, that's the cost or the remaining dollar value on the phone after talking for 10 minutes. Okay, so this is the remaining value on the phone after 10 minutes. That's what that means. And then part D says, well, what if f of x equals 10? And remember, f of x really just means y. What if y is 10? Find x. So now we take 10 and we plug it in for y, and we need to solve for x. So it's going to be 10 equals negative 0.15x plus 40, and your job is to solve for x. So we would do 10 minus 40, so negative 30 equals negative 0.15x, and then divide both sides by negative 0.15, and you get 200. Okay, so the answer is 200, but what does that mean? It means when there's $10 left on the phone, you had been talking for 200 minutes. Okay, so after 200 minutes on the phone, there is $10 left, or $10 credit left. And then lastly, a quick sketch of the graph. Again, what I need is the x and y axis. I need labels. So x stands for minutes, and y stands for value, or money. And we need the y-intercept. So the starting value was at 0,40. So you guys should have a dot here at 40. Okay, so what's our line doing? It's linear, so we know it's a line. We have a negative slope, so the line will be going down. That's it. Okay, you guys, this one's getting kind of long, so if you want to stop here, go ahead. If you want to see one more, I will do one percent one too. Okay, so if anyone's interested, I'll do one more percent one. You deposit $1,400 in an account that pays 6% interest compounded yearly. Okay, so A says, what type of model? When it's a percent growth or decay, it's exponential always. Now the percent problems, the model is y equals a times 1 plus or minus r to the t power. We might have used C before, but I'm just going to use A. Doesn't matter. All right, what do we know? A is the starting value, so 14,000. 1, let's see, we're gaining interest. They're paying us interest, so it's plus. 6% as a decimal is 0.06, and then to the t power. That's going to be our model. Now B saying, how much money will you have in your account after 10 years? So we're going to take 10 and plug it in for t. All right, so let's see, $14,000 times 1 plus 0.06 raised to the 10 power. And that means you will have $25,071.88 approximately. Okay, and then part C is just a quick sketch. So let's draw our x and y axis. Let's do our labels. The x value is time, and the y value is money. All right, let's get our starting value y-intercept. That's going to be up at $14,000. And it's exponential and it's growing, so it should be a curve going up. And then just a heads up, I won't do this one, but if it's depreciating, decreasing, for this one it's going to be an exponential decay. All right, thanks for watching, guys. That just kind of like ties everything together.